Today's the 26th of December, day after Christmas, and they're going to close the site down tomorrow, so I'm going to get finished with Chapter 8 today. This is our last section that we're doing on Chapter 8. Recall I had done some other sections before that were not actually included in the curriculum, and again, there's a lot of good stuff there, especially if you're going into pre-calculus, but you're probably busy enough doing your work as it is now. So this is problem solving and solving formulas, but we'll be using the quadratic equation, and then we may solve it by factoring, by completing the square, or general multi-purpose quadratic formula. And here we have somebody who's on a motorcycle. She rode her motorcycle 300 miles at a certain average speed. Had she averaged 10 miles per hour more, the trip would have taken 1 hour less. So as you may or may not realize, this is going to be a distance problem. So let's go on and take a look at what they've done. So the first thing we do, of course, is to familiarize ourselves with what's going on. So the trip is 300 miles in both cases. It's just that if her time was t, her speed is r. If her time was t minus 1, that is 1 hour less, her speed would be this. So in a sense, we have distance equals distance, and that's what we're going to set it up as. So they say in making a drawing that would kind of help us. And let's move it up a little bit. So we have distance is 300. Distance is 300. Your time is t. Your speed is r. For this one, it's 10 miles more, 1 hour less. So to carry out, we substitute from r from our first equation and solve the resulting equation. Well, we know that r is 300 over t, so there's our r there. So this is going to be 300 over t plus 10, and there's our basic equation. So again, going to chapter 6, where we had these rational equations, we want to get rid of all our fractions by multiplying everything by our common denominator here. Here, I guess they're doing this side and then they're doing this side. So here, the t's will cancel out and you get this. Here, nothing cancels out, so you get that times 10. Here, the t minus 1 cancels out. So it is a kind of a laborious process, and we're just getting to where we need to go. And then once we finish, we get it in standard form, and we can factor a 10 out of everything, and we get this. And at least this part is easy, because we can factor that. And then t here is going to equal 6, and t here equals a -5. So we're not in the twilight zone, so we don't have -5 time. Our time is going to be 6 hours. And I believe they'll probably check it for us. and they do. And they are asking us to note something here. Caution. Always make sure that you find the quantity asked for in the problem. I had mentioned this before. Now, when we solve this, we ended up with 5 hours. But they want to know, what is the speed? Ah. So the slower time was 6 hours. So 300 divided by 6 hours gave you what R was, which is 50 miles per hour. So this is challenging because you found the time, and I think I mentioned this a long time ago. It's shorter for me because I've been doing a lot of these lately. You have to answer what they ask you. Okay, let's go on. Okay, solving formulas here. Here we're dealing with the period of a pendulum. The time required for a pendulum of length L to swing back and forth, that is, one period of your pendulum is one back and forth, is given by the formula this. And I see when they have it this way, I don't like it, but then they switched it over to this way that I do like. Where G is the Earth's gravitational constant, solve for the letter L. Okay, let's take a look at this. The letter we want to solve for is L right here. Now, what I would suggest we do is to get rid of the radical sign, and that's what they're doing. They're squaring both sides. So you get t squared. This becomes 4 pi squared, and then this just becomes the radicand. Now that you have the radical sign out of there, we can multiply both sides by g. Now the g's will cancel out, and you then get this. And then now you're going to divide both sides by 4 pi squared to get the L by itself. And there's the solution. So this one wasn't too bad, so long as you remembered this technique. Now, is there possibly another way to do it? Yeah, you could have divided both sides by this first. And then squared both sides, but this way's good too. Okay. Okay, hang time. And this is from a formula down here. They have a little reference to it. I guess this is the amount of time that an athlete can remain airborne when jumping. Wow, you see this in the National Basketball League there. A formula relating an athlete's vertical leap. Okay, I'm not too familiar with any of this. V in inches to hang time, which is T, in seconds, is this. Solve for the letter T. So let me work this one out for you here. All right, so we have V equals 48 T squared. Well, the first thing I would do is I would divide both sides by 48. these would cancel out, and I would get t squared equals v over 48. In fact, I think you already know how to do this one. You're just going to hit the wrong button there, but you're just going to take the square root now of both sides. Okay. They have this on the next page here. Okay, divide both sides by 48, and then take the square root of both sides. Now, the key is, again, and I didn't mention that on the previous slide, is that once you take the square root of this, which is all of that, you get a radical in the denominator. So they do want you to simplify. This is going to be t equals the square root of v over the square root of 48 is the square root of 16 times 3 back from chapter 7. So this gives you 4 the square root of 3. Now what we have to do is rationalize, because they don't want a radical left in the denominator. So what we're going to do here is multiply this by the square root of 3. I was going to write it twice there. Over the square root of 3. We are rationalizing that denominator. So our numerator becomes the square root of 3v all over. Now, square root of 3 times square root of 3 is 3, or square root of 9. Square root of 9 is 3, and this becomes 12. And there's where you get the final answer. Now, if you had left it like this, you know, where it's sort of correct, it hasn't been simplified. And you never want to leave a radical in the denominator. So you have to rationalize the denominator. Okay, here's a falling distance, and we had done some like this, where an object tossed downward now with an initial velocity of this. This is your initial velocity. Will travel a distance of s meters, where s is this, and your initial velocity in t. Okay. So we have to do some substitution. So there's our basic equation, and you want to see, you want to solve for the letter t. Okay, well there's the t there, and there's the t there. Now, can you see this is sort of in a quadratic equation form, but since we want to solve for t, that used to be an x out there, x equals, we have to put it in standard form. So we have to transpose that s over to this side, becomes a negative s, and we have to be careful about how to put this v sub o in. Again, I'm not sure how they're going to do that in math lab, but anyway, what is our a now that it's in standard form? Now 4.9. Our b is our velocity. Our c is a negative s. And we substitute it carefully. And again, that's as far as we can go, because we don't know what our initial velocity is. They just want you to solve it for t. And notice that even though we have a plus and minus in our formula, we will only be interested in the positive root. And here they're showing you someone is throwing gloves down to someone who forgot their gloves on a very cold day. A little bit of humor, there we go. Okay, they're giving us that. And that will be our unit for Chapter 8. Now, there are various problems that we did in other sections. The same strategy, the 5-point strategy. Read it carefully, make a diagram, try to understand it, put a chart or whatever, make an equation, solve the equation, and in these cases now we can use the quadratic formula and then look at our answer and see which one fits. You often will get two answers. Often you'll be rejecting the negative one as not applicable. Okay, well, good luck on this.